In number 65, we're asked which line is parallel to the line y minus 3x is equal to 6. Parallel lines have the same slope, and in order to tell the slope of a line, it's easiest if you have the equation in slope-intercept form, or y equals mx plus b form. So in order to do that, we'll take the given line and add 3x to both sides, and so its slope will be 3, and then therefore the slope of a parallel line will also be 3. So we just need to pick one of the lines that has a slope of positive 3, and that is the line right there. In 66, we're asked for the equation of a line perpendicular to a given line. Perpendicular lines have opposite reciprocal slopes. So let's take the given line and let's move its equation into y equals mx plus b form. So subtract 4x from both sides, divide by -7, and we get y is equal to positive 4/7 x minus 4. So a line perpendicular will have an opposite reciprocal slope. The slope of this line is 4/7, so therefore the slope of a perpendicular line would be -7/4. And so we're going to pick a line whose slope is -7/4, and that would be choice E. In 67, we're asked for this to categorize the slope of this line right here. This is a horizontal line. Horizontal lines always have 0 slope. Another way to think of this is if we pick 2 points on the line, then the rise between those 2 points is 0, and the run is, for instance, for the 2 points that I picked, 3. And so that makes the slope the rise divided by the run, and 0 divided by 3 is equal to 0. In 68, we have a line with a slope of -1/3 and a y-intercept of 5, and we're to write the equation in standard form. If we're given the slope and a y-intercept, it's easiest to start with the equation in slope-intercept form, or y equals mx plus b form. M is -1/3 and b is 5. Standard form has no fractional coefficients, and it's in the form ax plus by is equal to c. So I'm going to clear the fractions first. Let's multiply all terms by 3. And then I'm going to add x to both sides, and we get x plus 3y is equal to 15, which is choice B. In 69, we're asked for the equation of a line that passes through a given point and is perpendicular to a given line. The line y is equal to 1 is a horizontal line because all equations of lines that are in the form y equals a number are horizontal. And so that means that a perpendicular line would be a vertical line, and all vertical lines have equations in the form x equals. The x-coordinate of the point that it goes through is 2, so the equation must be x is equal to 2. In number 70, we're asked for the equation in slope-intercept form of a line that passes through a point 2, -2 and perpendicular to a given line. The given line has a slope of 2/5, so that means that a perpendicular line must have a slope of -5/2. Since we have the slope and a point that the line goes through, we're going to use the point-slope form of the equation. Point-slope form is y minus y1 is equal to m times x minus x1. y1 is the y-coordinate of the point, and since y1 is -2, y minus -2 is also written as y plus 2. The slope is -5/2, and x1 is the x-coordinate of the point, which is -2. From here, I'm going to distribute the multiplication to the terms on the right side of the equation, so -5/2 x plus 5, and then subtract 2 from both sides, and we get y is equal to -5/2 x plus 3, which is choice D. In 71 through 78, we're asked to match the graph of a transformed function given the graph of the original function. So it's important to recognize what transformations have happened here. So for number 71, I see a -2, or a subtraction by 2, outside of f of x. Since it's happening to the outside of f of x, that means it's going to be a vertical transformation, and subtracting 2 moves the graph down by 2. So let's take a look at our original graph, and then let's translate that down 2, and we will get choice E. In number 72, we have f of x minus 2, but this time the -2 is affecting the inside of the function, or the input. Input transformations involve inverse operations, so we're actually adding 2 to each of the x values, which moves the graph right 2. So let's check out our original function, and let's pick the graph that has been moved to the right 2, and that would be choice J. Now let's take a look at number 73. Number 73, y equals 2 times f of x. That times 2 is outside of the function, so it's affecting the y variable, multiplying all the y's by 2. And so what that performs here is a vertical stretch by a factor of 2. So we want to look for a graph that is 2 times as tall as the graph of the original y equals f of x, and that would be choice D. For number 74, we have a -1 multiplication that's happening to the outside of f of x. That means that it's a vertical transformation, and multiplying by -1 flips the graph, so we have a vertical flip happening here. So let's take a look at our original graph, and let's pick the one that has been vertically flipped, or flipped over the x-axis, and so that would be choice B. For number 75, we have y equals f of -x. We have another -1 multiplication, but this time it's happening to the input. And remember, input input transformations are inverse operations. However, dividing by -1 and multiplying by -1 achieve the same thing. So this is also a flip, and this time it is a horizontal flip. So let's take a look at our original graph, and let's pick the one that has flipped horizontally, which means that it's reflected over the y-axis. So that would be choice A. Next, 76, we see an add 2 that's happening to the outside of f of x. That means it's going to be a vertical transformation. So the graph is moving strictly up 2. Let's take a look at the original graph, and let's pick one that has been translated up 2. And that would be choice F. Now let's take a look at 77. We see an x plus 2, but it's on the inside this time, so it's happening to the input operation, or the input variable, and that is an inverse operation in effect here, so that means we're going to subtract 2 from all the x-coordinates, which will move the graph left 2. So let's take a look at our original, and let's pick the one that has been moved left 2, or translated left 2, and that would be choice I. last 78, we see a times 1/2 that's happening to the outside of the function. That means it's going to be a vertical transformation. And since multiplying by 1/2 makes all of the y values smaller by a factor of 1/2, this is a vertical compression. So if I have a vertical compression, the graph will be half as tall as its original. So let's take a look at the original and pick one that has been compressed vertically. That would be choice C. In 79 through 83, we just have to pick the correct parent function for each graph. Parent function matches the function in its shape, but it can be transformed. So 79 is a quadratic function, or a parabola, and a parabola always has y equals x squared as its parent function. For number 80, we see a line, and the linear parent function is y equals x. In 81, I see a cubic function, so its parent function is y equals x cubed. In number 82, I see a square root function. It's just a half of a parabola, but it's sitting sideways. And so that's going to be the square root function e. And 83, we see a v shape. That's always going to be an absolute value function, so that would be choice B. In 84 through 87, we're graphing the function in the given grid, showing 5 anchor points if possible. You may use a table of values if you wish. What you can do here is many of you may choose to use the new origin. The new origin is reflective of what makes the inside of the function, or the inside of the cubing, equal to 0. So that's x value of -1, because -1 plus 1 is equal to 0. And then the addition or subtraction outside gives us the y value for the new origin. So I know that the new origin for this function is at -1, -2. I'm going to put an x there, and then I'm going to take the equation, and I'm going to take all the addition and subtraction out of it. So I'm going to take out that -2 and the +1. Now we're just left with y equals -x cubed. You can create a quick table of values for this. So I'm going to pick my parent function points, -2, -1, 0, 1, and 2, cube, and then take their opposite values and graph the first and last columns as the coordinates of the parent function, and then just graph them from the new origin. So -2, 8 is 2 to the left of the new origin and 8 up. Remember, that's all relative to the new origin. 1 to the left of the new origin and 1 up. 0, 0 is on the new origin. 1, -1 is 1 to the right of the new origin and 1 down. And 2, -8 is 2 to the right of the origin and 8 down. Now we get that cubic function shape. And for number 85, we have an absolute value function. If you like, you can change this to -3 times the absolute value of x plus 1. And so my new origin is the point 0, 1. There is no addition or subtraction on the inside of the absolute value. So the new origin has an x value of 0. So I'm going to take my equation and I'm going to take all of the addition out of it. So it's just -3 times the absolute value of x is equal to y. So x, the absolute value of x, and -3 times the absolute value of x would be the 3 columns that we would use. Let's use 5 anchor points here. Some negatives, some positives, take their absolute values, and then multiply each of those results by -3. The first and the last columns give us the points graphed from the new origin. So 0, 1 is our new origin. And then let's graph the points from the new origin. -2, -6 is 2 to the left and 6 down from the new origin. -1, -3 is 1 to the left and 3 down from the new origin. 0, 0 is on the new origin. 1, -3, 1 right and 3 down from the new origin. 2, -6 is 2 right and 6 down from the new origin. And this gives us this graph right here. We can graph some additional points here. Since both sides are linear, we can kind of use slope to graph additional points for accuracy. For 86, we have the square root function, and our new origin will be the point -2, 0. There is addition or subtraction on the inside of the square root function. -2 would be the number that would be the value of x that makes the inside equal to 0. And there is no addition or subtraction on the outside, so that means the y value is 0. Now let's create a table of values, taking all addition and subtraction out of the function. And so we have x, the absolute, x the square root of x, and -3 times the square root of x. The smallest number you can take a square root of is 0. 1 has a whole number square root, 4 is the next number with a whole number square root, and 9 is the next number with a whole number square root. Take their square roots, 0, 1, 2, and 3, and then multiply each by -3. And now let's graph those first and last columns as points measured from the new origin, which is -2, 0. 0, 0 is on the new origin. 1, -3 is 1 to the right and 3 down from the new origin. 4 to the right and 6 down from the new origin. And then 9 to the right and 9 down from the new origin. And remember, 0, 0 is an endpoint. The graph does continue and should have an arrow on the right side, however. All right, last one here. Let's take a look at this as a quadratic function. And our new origin has an x value that would make the inside of the squaring equal to 0. So x equals 2 will be the x value because 2 minus 2 is equal to 0. And then we have a -5 on the outside. Now let's take all addition and subtraction out of this function. That'll give us y equals x squared. So it means we're really just graphing the parent function. I'm going to use -2, -1, 0, 1, and 2 for x values and square to get the y values. Let's graph our new origin point. That's 2, -5. And graph the points from there. -2, 4 would be 2 to the left and 4 up. And -1, 1 would be 1 to the left and 1 up. 0, 0 is on the new origin. 1, 1's 1 to the right and 1 up. 2, 4's 2 to the right and 4 up. We can graph some additional points for accuracy if you wish. -3 squared is 9 and 3 squared is 9. So 3 to the left of the new origin and 9 up, or 3 to the right of the new origin and 9 up, give us some additional points for added accuracy to the graph. Now let's move on to 88. For 88, we have a piecewise function, and the easiest way to handle this is just to treat it in pieces. So for instance, I'm going to make a table of values. My x values less than or equal to 3, and my y values equal to 4. So less than or equal to 3, 3, 2, 1, 0, etc. And my y values will all be 4. Since there is an or equal to here, when I graph that very first point at x equals 3, that's going to be an endpoint, but it's going to be a closed circle when we graph. So 3, 4 is the first point, and then 2, 4 to the left of it, 1, 4. 0, 4. Gosh, that's just a horizontal line, so I'm going to graph a horizontal line that goes to the left of that initial point and continues infinitely. Now let's create a table of values for the second part. For this one, our x's will be greater than 3, and our y values will be 1/3 times x minus 2. So I'm going to pick x equals 3 anyway, even though x can't equal 3, recognizing that this particular endpoint will just have an open circle. That means that there won't actually be a point there, but we're going to graph it for reference anyway. So 3, when I replace x with it, I get 1/3 times 3 minus 2, which is 1 minus 2, or -1. So we have the point 3, -1 that's graphed as an open circle. It will be easiest for us if we're using a table of values to pick multiples of 3 since we're multiplying by 1/3. So I'll pick 6 and 9. 1/3 times 6 is 2. 2 minus 2 is 0. 1/3 times 9 is 3. 3 minus 2 is 1. So we have 6, 0 and 9, 1. And there's the rest of the graph. For 89, we have a two-part piecewise function again. So I'm just going to pick the two parts and graph. First part, our x values will be less than 0, and our y values will be x squared. Again, I'm going to pick 0, even though 0 is not included in the interval, but we're going to pick that point and graph it using an open circle. And so 0 less than would be negative, correct? So -1, -2, -3, let's use that much, and then square to get the y values. So 0, 0 is an open circle. -1, 1 closed, -2, 4 closed, and -3, 9 closed. So the graph goes to the left of x equals 0, continuing infinitely in that direction, and then has an endpoint with an open circle at 0, 0. For the next part of our table, we're going to pick x's that are in between 0 and 4, and the y values are x plus 3. So 0, 1, 2, 3, 4. For this one, we have two endpoints at x equals 0 and also at x equals 4. Since there are or equal to's on both of those are going to be closed circles. And there'll also be endpoints, which means there's not going to be any arrows on this side of the graph. 0 plus 3 is 3, 1 plus 3 is 4, 2 plus 3 is 5, 3 plus 3 is 6, 4 plus 3 is 7. Now we have a lot of points that we can graph. 0, 3 is our first endpoint, 1, 4, 2, 5, 3, 6, 4, 7 is the second endpoint. This has no arrows. It just starts at x equals 0 and stops at x equals 4. In 90, we're asked which two-variable inequality is shown in the graph. So first off, we need to determine what the equation of this boundary line is. This boundary line has a slope of 1 because the rise from one point to the next is 1 and the run is 1. It's a positive slope because the graph is rising as you go from left to right. Its y-intercept is 2, so its b value is positive 2. Don't confuse the y-intercept with the x-intercept. So the y-intercept is on the y-axis. So that means that the equation of the boundary line is y is equal to 1x plus 2. That eliminates some answer choices immediately. And next, we can also notice that the line is solid. If the line is solid, it is included, which means there is an or equal to. Next, we just have to determine where the shading is. The shading is on the bottom portion of the line. That means that y values are smaller than the y values on the line. That tells us this is choice F. For number 91, we're asked a similar question. So for this one, our slope is 1/2 because we have a rise of 1 and a run of 2. Remember, rise goes on top and run goes on bottom. That eliminates some answer choices here. And next, we have a y-intercept of -5. That doesn't eliminate any answer choices. Next, we'll also notice that the line is a dashed line. That means or equal to is not part of this. And lastly, we have to determine if there's shading above or below the line. Above the line indicates that y is greater than a certain value. So that means that we're looking at choice C. For number 92, we are asked what is the value of x in the solution to this system right here. So if I just want to figure out who x is, I'm going to take and eliminate the y's from this equation, from this system of equations. So I want to take and multiply that second equation by 2 because doing so, when we add the two equations together, we'll eliminate the y's. So I'm going to bring my equations over here. 2x plus 6y is equal to 5. And multiplying by 2, the bottom equation, we get 2x minus 6y is equal to 2 times 8, which is 16. And then adding the two equations together, we get 4x is equal to 21. And then dividing by 4, x is equal to 21/4. Notice that you don't have to solve for y in order to answer this question correctly. In 93, we are asked what is the graph of the solution to the system of inequalities below. So what you'll notice is that the boundary lines are the same for each of these answer choices, so we don't really need to worry so much about the boundary line. What we do need to worry about is which direction we are shading. So if y is greater than -x, that means that we are going to shade above. Or equal to is shown since the lines are solid, right? But the shading tells us whether it's greater than or less than. For the next inequality, it is not solved for y yet, so I am going to subtract x from both sides, and then I'm going to divide by -2. When we divide by -2, the inequality switches direction. Since we have a y is greater than, we're also going to shade above. So I'm just going to pick the graph in which the shading is on the top side of both lines. That would be choice B. For 94, we asked for the value of k for which the system has an infinite number of solutions. An infinite number of solutions happens graphically when you graph the two lines in the system and they graph right on top of each other. In other words, they share an infinite number of points. So let's take this first equation here and let's put it in y equals mx plus b form. So subtracting x from both sides and then dividing by -2, we get y is equal to +1/2 x minus 6. So if the second line is the same line, then k must have to be -6. So choice B is the correct answer. For 94, we're going to identify all ordered pair solutions for the system. And so we just really need to check each of the points and see if they are solutions to each. In order to be a solution to the system, they have to be a solution to both inequalities. So let's test 1, 5. So equation number 1 is x plus 2y is less than 11. And inequality number 2 is x minus 2y is greater than or equal to 3. So let's test 1, 5. 1 plus 2 times 5 is less than 11. That would be 1 plus 10 is less than 11, or 11 is less than 11. That is not a solution to that inequality. It has to be a solution to both inequalities, so I'm not even going to test the second one. Now, let's take a look at our second point. Roman numeral 2 is the point 4 comma negative 1. So x is 4 and y is negative 1. So that would give us 4 minus 2 is less than 11, or 2 is less than 11. That's true. Now let's test the second inequality and see if it works in that one as well. 4 minus 2 times negative 1 is greater than or equal to 3. That'll give us 4 plus 2 is greater than or equal to 3, or 6 is greater than or equal to 3. So while it's a solution to the first inequality, it is not a solution. Oh, it actually is, because 6 is greater than or equal to 3. So that one works in both. So 2 is less than 11, and 6 is greater than or equal to 3. Now let's test another point and see if it tests in both of the inequalities. So the point 7 comma 2, 7 plus 2 times 2 is less than 11. It would be 7 plus 4 is less than 11, or 11 is less than 11. That is not a true statement, therefore not a solution to the system. One last point to test. That's the point 5 comma 1. So x is 5 and y is 1. So 5 plus 2 is less than 11, or 7 is less than 11. That's true. And now 5 minus 2 times 1 is greater than or equal to 3. That would be 5 minus 2 is greater than or equal to 3, or 3 is greater than or equal to 3. 3 is greater than or equal to 3 because it is equal. It's got to be one or the other. So solution to both inequalities. Therefore, Roman numeral 2 and 4 are solutions, so choice G. In 96, we are picking the graph that is the solution to the system of inequalities. X is greater than or equal to 2 has a boundary line that is x equals 2, which is a vertical line, and the greater values are going to be found on the right side. Greater values of x are found on the right. And then y is equal to x is an oblique line, not vertical, not horizontal. And y is less than or equal to x means that we would shade below that one. So I'm going to pick the graph that has a vertical line shaded to the right and an oblique line shaded below. So, and that would be choice B. Beware, some of the answer choices had horizontal lines in it, so it's important that you know the difference between the vertical and horizontal lines equations. X equals vertical line, y equals a number, horizontal line. In 97, we have a system, number of systems. We're asked which one has no solution. No solution graphically means that we have parallel lines. And remember, parallel lines have the same slope, but they have different y-intercepts. If they have the same y-intercept and the same slope, they are the same line, but not parallel lines. Okay, if we look at A, if we were to solve these equations for y, the first equation would be y is equal to negative x plus 8. So it would have a slope of negative 1. The second equation, solved for y, is negative y is equal to negative x plus 2, or y is equal to x minus 2, and that has a slope of positive 1. Are these parallel lines? Nope. So that means we're going to eliminate choice A. For choice B, y equals negative x plus 3, which has a slope of negative 1. And for the second equation, 5y is equal to negative 2x plus 3, dividing by 5, we get y is equal to negative 2/5 x plus 3/5, which has a slope of negative 2/5. Are they parallel lines? Nope. They do not have the same slope. All right, let's take a look at C. For C, we have y is equal to negative x plus 4, which has a slope of negative 1. And then 3y is equal to negative 3x plus 10, dividing by 3. Y is equal to negative x plus 10 thirds, which has a slope of negative 1. Same slope, different y-intercepts. That means that these are parallel lines, so that system there would have no solution. Now let's take a look at D, just to talk about this answer choice. When I solve the first equation for y, we get a slope of negative 1. When I solve the second equation for y, we get 5y is equal to negative 5x plus 35. And then dividing all terms by 5, we get y is equal to negative x plus 7, which also has a slope of negative 1, but notice that this equation is exactly the same as the other. That means that these two lines are identical lines, meaning they graph on top of each other, not parallel lines. So this would have infinitely many solutions if we solve that system. All right, in 98, Marie has 22 coins and quarters and dimes with a total value of $4.45, and we're looking for a system of equations that could be solved to find the number of quarters Q and the number of dimes D. I'm going to create a table to organize my information here. So I have a rate, which I could measure in dollars per coin, and that suggests that we multiply by the number of coins, and that will give us a total dollar amount or dollar value for that collection of coins. In this particular scenario, we have a number of quarters, or actually D comes first, right? So let's write our D first in the table. We have number of dimes, and dimes are 0.05 per coin. I'm sorry, that is not right. That's a nickel. Dimes are worth 10 cents. Dimes are $0.10 per coin. And there are D dimes, that is the number of dimes. And so the value would be 0.10 times D. The number of quarters involved. Quarters are worth 25 cents per coin. And Q is the number of quarters defined by the question. And so the value of the quarters is 0.25 times Q. Now we also have totals. The total number of coins is 22. The total value of the coins is $4.45. So D plus Q is equal to 22, and 0.1 D plus 0.25 Q is equal to $4.45. That's choice D. In number 9, we have a rectangle that has a length that's 3 inches more than twice its width. I'm going to draw a picture. And we have L and W. And which system could be used to find its length and width in inches? So, first thing, the rectangle has a length, and the length is 3 inches more than twice its width. So the length equals 3 inches more than twice its width. Twice its width is 2 times W, and adding 3 gives us 3 more. There's one of our equations. That doesn't actually narrow anything down. The second equation is going to be the clincher for us here. The area is 65 square inches. And the area, if the area is equal to 65, then area of a rectangle is length times width. So length times width is equal to 65. That's going to give us choice B as the system of equations. For 100, we have a mixture problem. A solution that is 40% acid and another solution that is 25% acid are mixed together to yield 250 gallons of a 28% solution. So we're looking for the system of equations to solve this mixture problem. So let's set up a chart. And my word key here is a percent of each of these solutions is acid. So percent, and then times for of, and then the amount of the solution. So the percent times the solution equals, or is, the acid content. For a mixture problem, we actually generally have 3 rows. The percent of the first solution that we're mixing together is 40%, and that will be written as decimal form, 0.40, and the amount of the solution is x, that's defined by the question, and so the amount of acid contained there would be 0.40 times x. The amount acid content of the second solution is 25%, so written as a decimal, that percent is 0.25. And the amount of that solution is y, so the acid content for that solution is 0.25 times y. The mixture is going to be a 28% solution, so 0.28 is the percent, and there are 250 gallons of that mixture. 0.28 times 250 is equal to 70. And so now we have our equations totaling the amount of solution. X plus y is equal to 250, and 0.40x plus 0.25y is equal to 70. And so that would be choice C. For 101, when traveling against the wind, a hang glider travels 5 miles in 15 minutes. When traveling the same direction as the wind, the hang glider can travel 7 miles in 15 minutes. Which system can be used to find the airspeed and the wind speed? So it's probably easiest if we set up a table, and the airspeed and wind speed are rates which are measured in miles per hour. So miles per hour times number of hours is equal to miles. And for the first trip, where we're traveling against the wind, the rate would be the airspeed minus the wind speed, because the wind speed subtracts from the rate. And for that trip, the hang glider travels 5 miles in 15 minutes. 15 minutes is 1/4 of an hour. For the same trip going the opposite direction, this time we're traveling with the wind, so the rate would now be a plus w, and for that one, the hang glider can travel 7 miles in also 15 minutes, so that would be 1/4 of an hour. Now remember that miles per hour times hours equals miles, so if we take this first row here, the number of hours times the miles per hour will give us the number of miles. And for the second row, 1/4 times a plus w is equal to 7. Distributing, that's going to give us the equations in, looks like choice F here. Okay, for number 102 and 103, we have the elimination method for this system of equations. Elimination method means we multiply one or both of the equations by a specified number and add them together in order to get one of the variables to eliminate or add up to 0. So I'm going to notice that 12 is a multiple of 4, so I'm going to multiply this second equation here by -3. And I'm going to copy these over here. 7x plus 12y is equal to -23. And multiplying the second equation by -3, -15 times x minus 12y is equal to -33. Adding the equations together, we get -8x equals -56. Dividing by -8, x is equal to +7. Remember, the solution to the system is an ordered pair, so we still need the y coordinate. And so I'm going to take equation number 2 here, the original one, and I'm going to replace the x with 7 and just solve for the y value. So 35 plus 4y is equal to 11. Subtracting 35, we get negative 24, and then dividing by 4y is equal to negative 6. Remember that your solution must be given in ordered pair format. That means parentheses and a comma in between, with x as the first coordinate and y as the second. For number 103, we're asked to use the substitution method. I like to use a 2-column approach. So let's write one equation in one column and the second equation in another column. Of the two, pick the easier of the two equations to solve for a variable. It is much easiest, or the easiest thing to do to solve that second equation for x. Now let's take that and replace the x in the first equation with 6y plus 9. So 2 times 6y plus 9 plus 3y is equal to 8. And distributing, combining like terms, and subtracting 18 from both sides. Y is equal to negative 10/15, which is negative 2/3. Now we're going to take that information and go back to the second column here and replace the y with negative 2/3 and solve for x. Negative 2/3 times 6 is negative 4. Negative 4 plus 9 is 5. And so given an ordered pair form, 5 comma negative 2/3 is the solution to this system. For 104, we're asked to write an augmented matrix to represent the system and not to solve it. So in order to write an augmented matrix, we have to have equations all in standard form. So the first equation is not in standard form. We need for it to be ax plus by plus cz equals d form. So that means that we need all of the variable terms on one side. So I'm going to subtract the y and add the 3z to both sides. And now it's in standard form. Equation number 2 at first glance looks like it is standard form. However, that 2 is a number and not a variable term. So I'm going to leave the 3x and the 7y where they are, and I'm going to subtract 2 from both sides. And lastly, the third equation is already in standard form, so we can leave that one alone. And now we're going to write the augmented matrix version of this. Remember, square brackets, vertical line to represent the equal sign, 4, negative 1, 3, 8 across the top row, 3, 7, 0, negative 2, don't forget to enter the 0, that's important, 5, 2, 1, 6, and there's our augmented matrix. Do not solve. In number 105, we write the system of equations that's represented and do not solve it. So this is just going in the reverse direction. Systems of equations have a brace that joins them together, 3x plus 0y, and you can write the 0y if you want, but you don't have to, minus 3z is equal to 5. Second equation, 2x plus 1y, which is just y, plus 5z is equal to 7. And the third equation, 4x minus 2y, and no z term for this one, equals 1. All right, in 106, we have an augmented matrix. And then this one, we're actually asked to solve the system and write the equation, or rather write the solution in ordered pair form. So the first row is 0x plus 0y plus 5z equals 10. So 5z is equal to 10 is really the first equation. The next is 3x is equal to negative 12. And the last is 4y is equal to 24. That's going to give us a z value of 2, an x of -4, and a y value of 6. In ordered triple form, the x comes first, the y comes second, and the z comes last. And so that's the solution to the system.